There you go. And we're recording. Hey, look at that stuff. Okay. Thank you, Kenny.
You're welcome, James.
All right, so we just created a freakout zone. This is an area in which all of a sudden in the next 20 minutes things are gonna get a little steamy. It's gonna get a little uncomfortable. You know, it's gonna be like, hey, I gotta get out of here, and all the bacteria is going to slide and reproduce down the water membrane that is covering everything that's in there, from the leaves down the sidewalls of the wood onto the rice media, because it'll say, hey, look at that, carbohydrate, sugars, how wonderful, it seems so much better than what I got right here. So it'll actually, the bacteria will travel by multiplying its cells, one on the other, and eventually end up in a genetics train all the way down to the rice. And then there it will inoculate the rice. The fungi, usually being water or wind dispersed, will either just drop in straight from the air, or do the same kind of function as the bacteria and slide along the water film that is on the side of everything that's in that box, eventually ending up at the rice. Okay? Well, what happens after 7 days of placing this in a cool, dry, dark area? Well, I'm jumping ahead of myself. What do we do with these boxes?
Put it in a cool area. Cool, dry area.
Right. Sort of. All right, there's two schools that say, one says put the box in the environment on which you got it from. I highly recommend that. Some people will say put it in your garage, put it wherever, put a tent over it, make sure it's protected and all that. I would agree with that too. It works. I would say from my microbiological standpoint that it makes more sense to place this material back into the environment in which we got it. Wow, there's fire ants out there. So what I would do with this is probably deep within those ferns right there, or maybe even over by the compost area, and then take piles of the leafy material and put it up over top and make a cool, dry area away from sunlight that is actually in the environment. So IMOs, it's probably best to leave these in where they came from, right? So place it out in the environment. Come back in 7 days and hope to God that the flies didn't get to your rice. This is a major issue with people who are making IMO. What happens is flies will get in, one maggot will start decomposing the material, another maggot comes along, eventually the stuff turns to mush and it becomes anaerobic and it becomes gross and stinky. What's the best way to prevent the flies from coming? Maybe make 2 boxes so that if one gets messed up, the other box is probably okay. I always make 2 boxes at once because 50% of the time that first box gets rained on, something happens, a pig comes along and eats it, it just happens. So I always make 2 boxes when I do IMO 1 because I've learned my damn lesson that if you do it and then you gotta wait another week to do it again, and you're a week behind, and then it's cumbersome. So I always make 2. It's up to you.
But you can definitely cover this completely.
Yeah.
With the debris and stuff like
that.
Yeah.
Right. Put it out in the environment, cover it in the debris. That's what I would typically do.
And the plastic's there to keep rain out, right? And also
to keep rain out and to increase the moisture in there and the heat that's in there, so that everything starts to freak out and want to get out. Okay? So Tuesday, I was given rice, or Monday I was given rice. Tuesday I came out and made some IMO 1 for you guys, and we'll see how it turned out. I don't think we have very much activity going on because it really hasn't had much time, but let's take a look. So that's IMO 1, guys. We're starting IMO 2. IMO 2 is after the material has been inoculated and then fermented. So we're not quite at IMO 2 yet. This is still IMO 1, but we're going into the IMO 2 phase. Okay?
Quickly, yeah, inoculation, again, the definition
Is taking a microorganism or pretty much anything from another environment and putting it into another. Okay? I didn't put down a metal grate. Sorry about that. Oh, hey, look, my camera disappeared. I wasn't too worried about mice.
That's all it's for?
Yeah.
Rodents?
So, I made a box here on Tuesday. Took it home with me. I should have left it here. I took it home with me. I put it in my barn and let it sit, but I went out there Wednesday to check on it, and it was just riddled with fire ants, which I have at my place. So I wasn't about to bring that box here. So on Wednesday, I made this box. So that's why I'm saying there's probably not too much inoculation going on, because we've only had 2 or 3 days of things to go on. But regardless, you don't have to put the metal grate on. You can put it in contact. I do it all the time as long as there's not really a rat issue. I'll do this. If I'm going to take this and put it in my barn, I'm not too worried about the rats. They don't come in there. Plus I have traps and stuff. So Gil says don't let it come in contact. I say it doesn't really matter. Believe who you want. But regardless, there's IMO 1. And what we would do is, if there was a metal grate on here, we would just take the material and push it off. It's an okay inoculation. Not what I would call finished. Okay, so can you guys see? We got cotton candy like fungi around the top. I stick my finger in here. It's really moist, really warm in the bottom. So there are spores and bacteria and things moving around. I would like it to be a lot hotter. I would like it to actually be right around 100 degrees. This is probably right around 89, 90 degrees. Oh, over here it does. I guess if you find the right spots, like right in here.
That's one right
So yeah, so you have mycelia right in this spot. So anyway, the picture that you saw in my PowerPoint presentation this morning with the mycelia, the white fungi growing all over the place, that's what this would look like after about 5 or 7 days of actual fermentation. So that's what I hoped you guys would look at today. But we know what it looks like, right? So after 7 days, you don't touch it. You just come on out, and you're going to see grays and greens and yellows and a lot of that cotton candy style mycorrhizae that's up on top. Okay? And then we'll go into IMO 2 phase. Everybody knows what we should be seeing here. Sorry about that. Write a letter to my office.
What should it not look like? 'Cause, like, you can get like really, like,
It should not look like black. It should not look heavy on the gray side. Greens are bad. It shouldn't be soggy or soupy. There should not be any maggots or any kind of insects. There should be maybe some insects crawling around, but no larvae actually consuming the material.
So it really needs to be just that white covering. Just mostly white.
It depends on where you sampled from. I mean, you can get peaches. There's a lot of peaches. There's a lot of yellows, almost like a sulfur color yellow.
But it's going to be kind of uniform over the whole thing.
Every batch is different.
Oh, okay.
Yeah. So actually, what you'll get is zones of production. You'll have like pink spots, gray spots, and then you have the white kind of branching all over, and maybe some gray film. And what you get is really some this sucks. I'm sorry, guys. What you do is you get a really nice layering. You can see. So that would actually be permeating all the way through to the point where if I stuck my hand in a finished batch, I'd pick this up like a piece of cake. It wouldn't fall apart like this. The mycelia just holds it all together.
Does it still look like rice in there?
It does look like rice, but it looks like rice with cotton candy mixed in it. Okay? I do apologize about
So
that.
it's on your right hand, but throughout the whole thing.
Yes. Throughout the whole thing, but even thicker. Even thicker. So, when it's all done, we peel back the permeable layer, we have our exposed microorganisms, and if this thing was totally riddled, we would move on to IMO 2, and let's do that.
It'd be like kind of like rice cake.
Yeah, like
the
a
texture.
cake.
Yeah, rice cake. You know rice cake? You know rice cake? You know rice cake? Put on Chinese food and ask for rice cake.
Oh yeah.
You'll
rice
get
cake.
that texture right there.
Unbelievable.
That's yummy. Good though. No, I like that food. It's getting more and more expensive. Buck hat. Used to be a buck.
Rice cake.
Prices stay elevated, but the size gets smaller. How do you figure that, man? Chinatown used to have the old man come with the most wonderful hand.
Okay, on a 1-to-1 ratio by weight, a volunteer is going to take this rice, put it in that bucket, we're going to mix it with sugar. Who's up?
I guess I go. Coors Light. You got lucky.
Again, it's important to make sure the plastic bucket is this type of bucket, not the other type of bucket.
Yes. This is very important at this phase that no light is getting into the bucket.
Now, have you ever done it on such a scale where you use like a 55-gallon drum?
For this phase,
Yeah.
there's really not any point because I can turn, provided these were totally riddled, I could turn that into
Right.
acres and acres of this stuff. It just takes time and materials. Okay, so we take our rice material that has been totally inoculated. It's so unbelievably awesome. We can't imagine, we couldn't pack any more microorganisms in here. We have great imaginations, right? Okay, 1-to-1 ratio by weight. Well, I know how much rice is in there. It's about 3.5 cups of rice, and when it's done, that weighs out about 6 pounds, because I've done this so many times. So you're going to put about 6 pounds of rice in there.
Sugar.
I'm sorry, yeah, I switched mine.
That should be good, yeah?
There you go. That's good. Okay, go ahead, volunteer, and stir that around with your hand until it's just like the fish or the fermented plant juices with a piece of sugar touching every kernel. Just like the fermented plant juices, I tend to put a little bit of water in here to kickstart this process. It has nothing really to do with osmotic pressure. What it has to do with is having enough moisture in there so that we can create anaerobic conditions. If there's not enough moisture in here, what you're gonna get is crispy rice, super dried out rice, and that's not what we're looking for. We're looking for that sugar to really pull the water that's in that rice out, and usually we got to put an extra splash of water in there.
That'll be a value-added product right there, man. I just invented something.
You don't want for you to be up like that.
Yeah. How would the guy just make 60 right
I think it's water in there creates the anaerobic
So, on the first step, I cultured microorganisms. I didn't really care what the microorganisms were. Now I'm starting to isolate and choose which microorganisms I want involved in my system. The first step is to create anaerobic conditions so that pathogens have a really hard time existing, because most pathogens need oxygen to sustain themselves when they're away from their plant hosts.
Why does the water make it anaerobic?
The water,
That was me.
does it make it how does it make it anaerobic? Well, essentially, oxygen is cut off. from everything below the surface
Below the surface of the water.
of the water, right?
Okay.
I think I added a little bit too much water, but it's close.
More sugar.
You had just the ideal amount of water for this ideal mixture we got going here.
Ideal amount. Perfect.
It is ideal.
It is ideal.
It is wonderful.
Actually, it's really not that bad. So what we just created was, right,
So slightly soupy.
slightly soupy, almost like a Vietnamese rice gruel.
Okay.
If you've ever had that, it's delicious. That material itself has what? Indigenous microorganisms, or whatever you want to call them, on the outside of those rice kernels. You just mixed it with glucose, which is the #1 choice of energy for all microorganisms. They will always go to the glucose first.
They're stoked.
It's a party.
And we just created anaerobic conditions, which will facilitate fermentation. You cannot have fermentation without anaerobic conditions.
Okay, and the fermentation will help select out.
Yes. Yes. And add lactic acid bacteria to the whole situation, because the end result of fermentation is lactic acid bacteria.
Always.
Always. So, anaerobic conditions, we just gave a food source to the microorganisms, but they're in an environment that they're not going to take advantage of the food source for reproduction, right? They're in an environment that they can't spore out. They can't necessarily do what they need to do. So, but there's this energy source around. So what do? They store it. They absorb the glucose through their cell walls, and they wait for something to happen. Most of the microorganisms that are in here are going to die in the next 7 days. The ones that are left over are the ones that can withstand anaerobic conditions, high alcohol levels, temperature change, environmental change. These are hot dogs, man. These guys are the hardcore dudes,
These are the
right?
guys that live at the bar.
Right? So, 7 days, a t-shirt over top. Whew. Where'd that go? No worries, there's plenty more. Got it? T-shirt up over top. Because you still want to have some gas exchange during fermentation. If you put a lid on this, you're going to have issues. Right? You're going to have methane gas, you're going to have all these decomposition gases being expelled, and there's nowhere for them to go.
So this is still anaerobic even though it's not sealed.
Yes, because everything below the line of the watery stuff there's no oxygen. There's a little oxygen because it's part of the sugar. You know, there's oxygen molecules in the sugar. There's a little bit of oxygen. The microorganisms have that. But over the next 7 days, that oxygen will be completely depleted. Okay? That is IMO 2. You see why we make IMO 2? First step, kill off a bunch of bad guys and make things uncomfortable for the ones we don't want. Second of all, this is the bacteria phase. Bacteria thrive in anaerobic conditions. So what we're doing here is we're making it tough for a lot of pathogens, but at the same time, a lot of bacteria are really comfortable in the situation. They got glucose, they're in anaerobic conditions, they can start doing some major reproduction. And so at this phase, fungi is pissed, but bacteria is having a great time. Okay? IMO 2, everybody. Hey, look, I got some finished IMO 2.
Yeah, totally.
After 7 days of processing, this is what we're going to see. Go ahead and take a look at that, guys.
Seven days later.
7 days, right.
So why is 7 days? That's just as long as it takes.
This is about how long it takes before you get that smell of booze and the
Smells good.
fermentation.
So any more, if you left it for 10 days, then it could be ruined?
No, 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 no. This phase is, I'm pissed, I'm gonna run out of battery here. That might have some on it. When this dies, I'll check. So this phase, IMO2, is a great point to stop if you need to. IMO2 can sit like this for an incredibly long period of time. As long as you keep it in a vessel that allows for gas exchange, but not evaporation. What's the best vessel for that? You ever seen those little clay pots, pinch pots that go up to the top with almost a vase-like top?
Oh, okay.
Very, very narrow. Get it in one of those because it'll allow for gas exchange, but a lot of the moisture will hit the top of the jar and then come circulating back around. And then even that, you put a little t-shirt or a little piece of fabric up over top, holds the moisture in. That's probably the best vessel to hold onto this material. I collect IMO2. I love to go out and make IMO2 in bunches of environment and then actually bring those materials together to make a killer IMO3. So yeah, indigenous microorganisms, natural farming states, use what you get in your environment. I've been doing a lot of experiments with getting just IMO2 from all over the place and then just combining them together and making some killer IMOs. Those fungi and bacteria, they do just fine in those other environments, so they're just not adapted to what I got. If you just increase the biodiversity and I do like 3 or 4 different batches from 3 different elevations, I'm just getting 3 or 4 different sets of microorganisms, okay? So if the Apua system, if you want to switch IMOs with your neighbors, it could be recommended. Some people do it that way, okay? So IMO can sit like this for a very, very long time as long as you have it in the right vessel. It's like Vietnamese rice gruel.
So could you seal it? Or is that not a good idea to seal it?
I would not seal it because it's still fermenting. It just continues to ferment until the rice is totally broken down. After the microorganisms run out of a food source, they go dormant. They don't die. They take a nap until you take them out, mix them with water, and add them to an aerobic condition. Then they wake up. Okie doke. It's IMO2. Let's go into making IMO3.
Could you eat that? No, seriously. Could
Not
you eat
eating
that?
that, man. I have a hard enough time with fermented food as it is.
You said you can stop at IMO2. How would you apply that?
What do you mean?
Well, it's
Oh, no. I'm saying you could stop. So, like, for instance, I'm doing a research project right now, and I made some IMO2, and long story short, I took the IMO2 that I made at all my sites home with me, like an idiot, right? My IMO3 piles got messed up, and I should have left the IMO2s in that location, and then I could have just worked from there and made another batch of IMO3, but I took them home with me, and then now they're all compromised. Now I gotta restart. That's my fault. But what I'm saying is,
Kind of a disaster. across
So
the-
compromise means other bacteria got into yours and was stronger, and so now you have some.
Well,
Can
my-
I field this question?
Yeah, go ahead.
Compromise would mean that James went to Guam and left me in charge of it, and I
Oh,
waited about 10 hours too long, and I cooked all of his piles.
But anyway, the point is, what was my point? I have no idea. What were we
You can
talking about?
stop at 2 because you don't.
Oh, I can stop at 2. I can leave it in this bucket, put it out in the environment that I got it from, and just put a little tarp over it, and then just leave it there forever for like a year or 2. And then come along, and when I'm ready to make IMO3, I can then make IMO3. So it's a place to stop. It's a place to stop. My point is, I should have stopped before I left for Guam with my IMO2 and said, oh, I'll make that when I get back. No, I kept going forward, and that's why I got messed up. But anyway, what I'm saying is, IMO2, you can stop, put it on hold, do what you need to do, figure out if you got the right materials. If this is a stopping point. There are no other stopping points. This is the only one where you can chill out for a minute and figure out what you need to do.
Do you have to use all of this for IMO3? Could you like take some?
No.
Yeah, so that you could just hold on.
Yeah,
to
you
this.
store it.
Yeah.
So this batch can make, God, you can make 20, 30 batches of IMO with this IMO2. So remember when I said you don't need to make these materials all the time? Even more so, all you need to do is have IMO 2 on hand, and then you never need to make IMO 1 again, or until you run out.
So when we made the IMO 3 that time, we used most of the bucket, but you could just take a handful.
Actually, I took handfuls. I took,
you did take
yeah, I took 2 handfuls per
that's
batch.
right. That's right.
Yeah.
So then you would inoculate another box full of rice?
No, we'll get there. So IMO 2, that's done. Let's move on to IMO 3. We're gonna do it over there underneath the tree. I need somebody with lots of muscles to grab that HFM bag on the bottom, on the top. It's 60 pounds. Do we need that one too? Come on guys, we're all going over there.
Do we need this?
We need a bucket.
Oh no, you don't.
You need
grab that? Grab that.
Okay.
Not that one. We're taking the fish stuff and we are taking I need a jar of fish emulsion and I need a jar of the
You want the older?
fermented plant juice.
The little one or the? You want the old?
That's fine. And where's the fermented plant juice? I think it's that one right there. Okay,
So is this the mill? Is that the husk of wheat?